So here's A. We're going to check what we can to factor. This is a difference of squares. So you get x plus 7, x minus 7. X squared plus 14x plus 49 is going to be x and x. And plus 7 and plus 7. So it was not a surprise that we have something in common, but not a surprise that they're not perfectly the same because they weren't the same to begin with. Now, when we need a common denominator to add these, we ask ourselves, well, what's missing as a factor here? We're missing an x plus 7. So we multiply top and bottom by x plus 7. What are we missing in the second one? An x minus 7. And this is where you feel like mathematicians should not have used the word simplify for this kind of question. Because the denominator is now huge. It doesn't look more simple than what we began. And on the top, we would get 7x plus 49 plus 3x minus 21. I'm not sure who decided that simplify.
But whoever it was, we should go back in time and sue him.
So now we do have some common denominators on the top. 10x, 49 minus 21, 28, all over x plus 7, x plus 7, x minus 7. The top, you could factor out a 2, but that would leave you with 5x plus 14. That doesn't simplify with the bottom, so we could leave it like this. Or if you wanted to have the top, the top, 14, 5x plus 14. You could factor the top as well just to make sure that nothing could simplify. But both of those answers would be the simplified form. You do not need to multiply the bottom out. In fact, leave it factored. Leave it factored at all times because this is going to be huge if you do multiply the bottom out. Yes?
And the thing, in the answer here at the bottom, just puts 1x plus 7 and a little 2 after.
You could do that as well. You could have it squared. You'll notice the answer at the bottom also lists the non-permissible values. It says that x can't equal negative 7 or x can't equal 7 because that would make you divide by 0.
And dividing by 0 is bad.
And dividing by 0 is very bad. In a question like this on a quiz or a test, if I don't say to state the non-permissible values, you don't have to. Okay? I will specifically say simplify and state the non-permissible values if I wanted you to say that x can't equal negative 7 and 7.
And the non-permissible values are basically just a fancy name for the boom values.
The boom values, yes. So here's B. Nothing too surprising in B either, although it is a subtraction sign. So this is where you could run into problems when you're subtracting. I'll group those together. And 18 is going to be n and n. To get 18, 6 and 3. 6 and 3. The 6 is going to have to be positive and the 3 negative. And the second one, n and n, going to have 5 and 4. The 5 positive, the 4 negative. Wow, something exciting happens in this one. Okay? We want to get a common denominator, but you could cancel already. That would make this fraction more simple than it was before, and it will also make our common denominator smaller, which will be good. To put this as an equivalent idea, imagine adding 2/8 plus 3/4. No, 3/6. No, let's go 5/6. Okay. Looking at that fraction right now, because this question that we're doing is an equivalent idea to something like this that you've seen before. We already saw that we don't need to multiply this by 6 and 6 and 8 and 8 because there was a smaller one of 24, which you could do with 4 and 4 and 3 and 3. However, you see that our first fraction could be simplified. 2/8 could simplify to 1/4. And now my common denominator, which before I was making 24 when I did 3s and 4s, could be 12. And having a smaller common denominator means it'll be simplified easier and quicker. The same thing is happening here. We can simplify this n minus 3 right at the beginning. What's going to be left on top when I cancel this out is just a 1. So this fraction is the same as 1 over n plus 6. Now, I can't simplify anything in the second fraction because there's nothing identical there. But now when I look at what's missing, this one's still missing n plus 5 and n minus 4. So you're going to need to multiply the top and bottom by that. Now this one, it's only missing the n plus 6. And so now we're going to get n plus 5, n minus 4, subtract n minus 2, n plus 6. And now I would have a common denominator of n plus 5, n minus 4, n plus 6. Will I have any like terms on top? Well, the only way I would have like terms, I'd have to FOIL this out first. FOIL this out. You cannot cancel these because right now this subtraction makes this whole thing grouped together. So you want to, it'd be fun just to cancel everything out. But that minus sign in the middle means that's grouped together. And so first of all, we'd have to FOIL things out. And it'll be n squared plus 5n minus 4, and it'll be n minus 20 minus, and notice I'm going to keep brackets here because we're subtracting. We're subtracting all of this. So I'm going to expand it, n squared. I'm going to have 6n minus 2n plus 4n minus 12. I'll FOIL it out in its entirety, but I'll keep brackets around it because we need to subtract all of it. This negative sign is going to get distributed to each thing. And although you might want to be lazy, you can't be. You have to rewrite the bottom out. So a couple of things as far as showing your work. At the beginning of last year, when you were first foiling, we would have shown all the arrows and done n squared minus 4n plus 5n minus 20 and had two things that were like terms that you would have to combine in the middle to be plus n. You can still do that. However, if you're getting stronger in your math skills and you can do that and combine those like terms in one step, especially when you have to rewrite the denominator every single time, it's nicer if you can do that. But you can write out more steps if you like as well. And now we're going to subtract, and I've drawn the arrows there. We're still going to have n plus 5, n minus 4, n plus 6 on the bottom. And on the top, n squared minus n squared is going to go away. N minus a 4n is going to give us negative 3n. And negative 20 minus a negative 12 will give us negative 8, because that's negative 20 plus 12. There are tons of places where you can make a small error and come up with a little mistake. Okay? Also, in a question like this, if you don't recognize that you need to get rid of the n minus 3, okay, what there would have been is an additional n minus 3 here. And then you would have 3 things to multiply together, which will be n cubes, and very hard to simplify. So just as another strategic thinking, we're not going to ask you on an exam to have n cubes on the top. So if you get that, something, oh, maybe I should have simplified early so that this isn't there, to help you think that through. Yes? Yeah, I'll move it back down. Again, we check our final answer. This is grouped together. You could factor out a negative if you wanted to. But nothing's in common, so that would be our simplified final answer. Put a circle around it. And the questions we can do are 6, 7, 10, 12, and 13. Six, 7, 10, 12, and 13. We'll quickly finish up our last example.